Solution to homework number 16, problem 1. Well, we have this cantilever truss with 600 pounds on it, and have dimensions where everything is 6 feet here in the horizontal, so 6, 6, and 6. And this is 12.5, even though it should probably be AH instead of AB, but oh well. And then this is supposed to be 4 feet. Okay, so I think some of the numbers that I previously used in my calculations here when I did a little quick run through are a little wrong, so I need to be careful there. All right, so we want to determine the forces in AB, BG, and GF using the method of sections. Okay, so away we go. Boom. Here, I've written the thing out. Okay, so my plan of attack here, some of the things I'm missing some information, or it looks like I'm missing some information, but we can find what these lengths are going to be by way of similar triangles. We could do that. I decided to instead use angles for this, right? So I'm going to draw like just a little side little thing here, and so from this right here, and once again there's actually like little schemes and stuff that we could do. I might show one other one. Okay, so if this is 12.5 and this is 4, then this one here is 8.5, right? Because this is 4 and this is 4, and this is, each of these is 6, this is 18, right? So theta is going to be the inverse tan of 8.5 over 18. And I did not calculate that before. So, boom. That's 25.28 degrees. Now, once we go to get the when we go to get some other dimensions, that's going to help us out. Another way to do this, and I wrote this wrong, just so you know, this should have been 4 right here, and so that would have been 4 right there, right? So I could say that this I could extend the triangle out to where it meets here at the end, and then say x divided by 4 is going to be equal to 18 plus x divided by 12, right? So they're similar triangles. So I could find out what that parameter is. And then for finding any of these other lengths right here, I could just do the same thing of the proportion of this distance divided by that distance right there. So that's like one of the approaches that I could have taken, but I decided I would rather go by this angle right here, and then I could just figure out essentially making kind of like a trigonometry thing. All right, so to find AB, I'm going to make a cut through AB, and then through AG, and then through GH, right? So what's going to be left over right here is going to look like, and I'm just approximating there. There you go. Going to have that. It's going to come up like this, down like this. I guess I'll draw the other diagonals in there. Although there should be about the same. Okay, and so I'm going to take some of the moments about G, and so this is going to be my F GH, and this is going to be my F AG, although I don't care, and then this is going to be my F AB, and that's the one that I want to get. And this is my, what is it, 600? Yeah, 600 pounds. And here's an FBD of this. Okay, so I'm going to need this dimension, right? So we're going this way, parameter, I need this dimension, which I might call YBG. All right, so YBG, and I have to think off the top of my head here as I'm going down, as I'm going through this, is going to be 4 plus, right? So the yes, okay. So it's going to be this 4 plus let's go 4 plus whatever that's going to be. So that's going to be the rise. So multiply it by the run. So it's going to be 12 times the tangent of 25.28, right? So this is the run, and so this is going to give me the rise, right? And so I easily just could have written 12 times this 8.5 over 18 right there, right? But I didn't. So, tired. Tangent, 12 and 4, and I get 9.667 feet right here, right? So I do the sum of the moments about G is equal to 0, and so here we go. FAB times 9.667 and is going to be minus 600 times 12. So FAB is obviously in tension, right? Keeping the thing from rotating around there. And 600 times 12, and we get 744.8 pounds and in tension. Now the next one we wanted to get was BG. All right, so that's going to be between here and here. So my strategy for that one is to cut it just a little bit differently, just a little bit over. So I'm going to cut this guy. I'm still going to have FAB, and because I know that, that's going to help me a little bit, just a little bit. And we're coming down here, but we're not. We're going to cut it like right here now instead. Okay, so we do have this coming back into here still, and we still have this coming down, but we're going to come down and have that and this right there. And so now we're going to take the sum of the moments about F. Oops, I should. Sorry about that. Right here. So we have F BG, and we have F GF. FFG. I prefer to go alphabetical order right there, right? So we're going to take the sum of the forces. All right, we still have this force coming down here. Boom. We have our 600 pounds, and this is still an FBD. So we're going to take our sum of the moments about F, and that would mean we need this dimension right here, right? So let me make room. So just like I had before, I have to find y, and that's going to be CF, YCF. So it's going to be equal to 4 plus 6 times the tangent of 25.28. And we could have just as easily used the ratio of the thing. So it's going to be 4 and 6, 25.28 tangent times plus. So that comes out to 6.834 feet. So we have the summation of moments about F now. I want to do it again. And that's going to be FAB. It's going counterclockwise, so 744.8 and times 6.834. And now we're going to also have counterclockwise is going to be FBG, and that's, I'm just assuming it's going downwards right here. It could be in compression, by the way. We could find out. We'll find out in a second. That's going to be 6 and 6. Nope, just 6. Sorry, it's coming along here. 6, and then minus 600 times 6 equals 0. So in FBG, let's try this out here. Okay, so 600, oh shit, man, that scared me, times 6, that's 3,600, and then we're going to take 744.8 and multiply that. All right, so this comes over here and becomes positive. This comes over here and becomes negative, but it's a larger number. So, and then we divide by 6. So I get a negative 248.3 pounds. So 248.3 pounds compression. And then this last member right here, I think it's going to be easiest to just take the sum of the forces in the x direction right there, right? Because we know that angle. So it gives me a little bit of a Benny that I used that angle right in here, that theta. I could barely watch that in there. So the sum of the forces in the x direction equal to 0 right in there. And so we go negative 744.8 right here. And so you could tell just nothing else is coming in here. So you're going to have a negative FFG times the cosine of 25.28 equals 0. And FFG is therefore going to be negative. So it's obviously compression. I drew it though left, so I'm going to put it down here. I'm going to put it down there as left. And so we go 744.8, 25.28 cosine divided, and so we get a negative 823.7 pounds, or 823.7 pounds compression. Fortunately, we don't have enough room, so I will use another page to summarize. Seems like waste, but you know what? They'll make more paper. And answers. If I had planned this out better, wouldn't have to do this, right? But I didn't, so I do. You know what I'm saying? FAB is 745 pounds tension. FBG is 248 pounds compression, and FFG is 824 pounds compression. All right. I hope I didn't make any mistakes, but so be it. You get the idea. It's the idea that counts more than the final thing. So that's a 15-minute video. If I make another 15-minute video, I might be able to go home. It's like 10:30 at night.